Hello and welcome to today's class. For today's class, we're looking at how to find the derivative of y equal to sine inverse of 3x plus 1 minus square root of, in bracket, minus x squared plus 6x. Now, it's kind of bulky. So what we'll do is very simple. We'll break them down in twos. So I'll solve this one separately, keep my answer, and then solve this one separately, and then finally I'll combine both answers. So how do I solve this? So first things first, I'll pick up this man here. So ignoring this for now, let y be equal to sine inverse of 3x plus 1. So first things first, I'm doing the inverse trig differentiation of sine inverse, of course, of this term here, 3x plus 1. So first things first, we'll say let u be equal to the term in brackets, that's 3x plus 1. If I differentiate u with respect to x, I will have that du over dx is equal to, this one gives you 3. So I have this. Also, from this same question, y is now equal to sine inverse of, so this becomes u, so it becomes sine inverse of u. All right, in our previous classes, we've looked at how to do the derivative of sine inverse. And we said, if I differentiate sine inverse from here, I will have that dy over du is equal to, if I differentiate sine inverse of u, that gives you 1 all over the square root of 1 minus u squared. All right, we already explained this in our previous class. So if you missed our class on inverse trig differentiation, simply check the description of this video. I'll provide a link to this differentiation. All right, so this is gotten. Let's now see what we have here. So from here, we'll now have that dy over dx is equal to dy over du times du over dx. And that's equal to dy du is this 1 all over square root of 1 minus u squared times du dx is this, that's 3. If I multiply this, I will have that dy over dx is now equal to 1 times 3. That gives you 3 all over the square root of 1 minus u squared. My final task is to simply replace the value of u as this one here. That's 3x plus 1. So that will now mean that dy over dx is equal to 3 all over the square root of 1 minus u. U is this, so that becomes 3x plus 1 all squared. Right, so I now have 3 divided by root 1 minus 3x plus 1 all squared. If you choose to, you can expand this and simplify. Okay, the question said expanding and simplifying all terms. Right, so I would have to expand this one here and simplify. If I have 3x plus 1, 3x plus 1 all squared, this will be equal to 3x plus 1 multiplying itself. And from the idea of binomial expansion, if you can remember when we did binomial expansion, from the idea of binomial expansion, if I expand all of this, this should give me, my final answer should be 9x squared plus 6x plus 1. Right. So after expanding this, I should have this one as my answer. If you're not sure of how we got this, simply use 3x to multiply 3x gives you 9x squared. 3x times 1 gives you 3x. 1 times 3x gives you 3x. So 3x plus 3x gives you 6x plus finally 1 times 1 gives you 1. So I have this for an answer. Hence, if I work on this, then this will now give me that dy over dx is equal to 3 all over, I'm having the square root of 1 minus, in brackets, so 1 minus this value after expansion gives you 9x squared plus 6x plus 1. So I have this. So it becomes 1 minus this. If I use the negative to multiply through, obviously this one goes here. So minus 2. Fine. Let me do my expansion. If I do my expansion, this gives you that dy over dx is equal to, I have 3 all over, that becomes the square root of 1 minus 2, this gives you minus 9x squared, minus 2 plus 6x gives you minus 6x, minus 2 plus 1 gives you minus 1. So obviously I can see plus 1 minus 1. So plus 1 cancels minus 1 and it's off. All right, so if this is true, that means my final answer should look like 3 all over the square root of minus 9x squared minus 6x. So I have this. Now we know from the idea of complex number that it's impossible to find the square root of a negative term. So what do we do here now? For this case, we have to factorize the negative. If I factorize the negative, that will be equal to, okay. So if I factorize the negative there, I will have that dy over dx is equal to, that becomes 3 all over, for this one here, I'm taking off negative from here, that would look like the square root of minus, in brackets, 9x squared minus 6x, or plus 6x, please. So minus to 9x squared gives you minus 9x squared, minus to plus 6x gives you minus 6x. My next task would be take this one outside, and that will be equal to 3 all over. This gives you the square root of, now we know from the concept of surds that if I have a surd such as root AB, this can further be broken down as being equal to root A multiplying root B. So with this concept now, we'll simplify this. If I simplify this, this will be equal to, this is minus this. And that's the same thing as saying minus 1 times this. In other words, this one becomes root minus 1 multiplying root this. So that becomes the square root of minus 1 multiplying the square root of 9x squared plus 6x. Right. So it becomes square root of this multiplying square root of this. All right, so I have this. Recall from the concept, but recall from the idea of complex number, we said it's impossible to take the square root of a negative term. And we said we use I to represent root minus 1. Now, if this is true, that means my final answer here would be that dy over dx is equal to 3 all over, this is I, so I into root 9x squared plus 6x. All right, so this is what I get from my differentiation, all right? Or if you want, you can still move this I to the back. So this one becomes 3 all over this I. Yeah, better still, you can put I there. With this now, we've only solved half of this question, right? We only picked this part and we simplify to get this. Our next task will now be taking up this part here and also differentiating. All right, so I'll just copy this one down here. Copy this down, that gives you. All right, so the next part of this question would involve picking up the second part and differentiating separately. So that would mean that for this, I'll have y equal to, I can choose to ignore the minus for now and just work on this. So that means y is equal to the square root of minus 9x squared plus 6x. Obviously for this, I'll have to use chain rule. For this, I'll have that y is equal to, first things first, this in index form would be minus 9x squared plus 6x Square root becomes raised to power 1 over 2. I have this. All right, so how do we solve this? We could choose to use chain rule shortcut, which is multiply by the power, what do you call it? Bring down the power, differentiate the question, repeat the question, subtract 1 if you want to. But then let me use the chain rule method. For chain rule method here, my first start is to say, let u be equal to the term in the bracket, that's minus 9x squared plus 6x. If I differentiate this, I will have that du over dx is equal to, if I differentiate minus 9x squared, 2 multiplies this, it gives you minus 18x plus differentiate 6x, it gives you 6. So I have minus 18x plus 6. Next up, would have that y is equal to all of this, which said should be u, that becomes u to power 1 over 2. So my next task will now be differentiate y with respect to u. So I will now have that dy over du is equal to multiply by the power 1 over 2 u subtract 1 over 2 minus 1. If I work on this, I will now have that dy over du is equal to 1 over 2 u to the power 1 over 2 minus 1 gives you minus 1 over 2. Rewriting this will be equal to 1 over 2 times, to take off the negative, take an inverse. So it becomes 1 all over u to the power 1 over 2. Again, I said to take off the negative, put 1 all over. So more like take an inverse. This inverse eliminates the negative here. So I have this. This one here in square root form becomes square root of u. So this one automatically becomes square root of u. So perhaps you can change this to square root of u if you want to. So root u. Such that if I multiply 2, I will have that dy over du is equal to 1 times 1, 1 all over 2 times root u, 2 root u. So I have this. All right. So having gotten du dx and dy du, let's now get dy dx. From here, we now have that dy over dx is equal to dy over du, that's using chain rule of function of functions, times du over dx. dy du is 1 over 2 root u. So 1 all over, that's this, 2 root u times du dx is this, minus 18x plus 6. If I multiply this now, obviously this one goes to numerator, so it becomes minus 18x plus 6 all over 2 root u. Trying to simplify as simple as possible, obviously this can be factorized. If I factorize this 2, that will be equal to, so divide this by 2, or factorize by 2 becomes 2, minus 18 divided by 2 gives you minus 9x plus 6 divided by 2 gives you 3 all over 2 root u. From here, this cancels this. So I'll have that dy over dx is equal to minus 9x plus 3 all over root u. Finally, I'll have to resubstitute the value of u into this equation such that, but we said u is equal to this, this one here. That gives you minus 9x squared plus 6x. All right, so therefore, we'll now have that dy over dx is equal to minus 9x plus 3, that's this, all over the square root of u. U is this, minus 9x squared plus 6x. So I have this. The only thing we can do here is to factorize. Possibly, you can choose to factorize this if you want to. You can bring out minus 3 from here if you want to. Okay, fine. So that's equal to, let's bring out minus 3 from here. If I take out minus 3 from here, it becomes minus 9x. So that's simply minus 9 divided by minus 3. Minus cancels minus. 3 here, 1. 3 here, 3. That becomes positive 3. So it becomes 3x. Divide plus 3 by minus 3. That becomes plus 3 all over minus 3. Plus minus is minus. That's minus. 3 over 3 is 1. That gives you minus 1. I'm having minus 1 all over my denominator. You can choose to still, oh shit. Can choose to still simplify this one too. All right, so this gives you the square root of minus 9x squared plus 6x. So I have this on simplification. The question said we should simplify as far as possible. So if that's true, we know again that it's improper to leave this one here as a negative. Okay, so we could choose to use the concept of complex number here, or we could simply invert them, right? Yep, we could simply invert them. So if they give us this, fine. Since this was given in the question there, I will choose to leave it that way. Since this form was given in the question, I'll leave it this way. So finally, we've gotten the derivative of this separately. We've also gotten the derivative of this separately. So my total dy by dx will be, I'll combine the answers for both this and this together to get my final answer. And that would be all right. So finally, we'll now have that if I'm given that y is equal to this, I'll have that my final answer, dy over dx, is equal to, after differentiating this one here, our answer was 3 all over square root of 9x squared plus 6x all to I. So we had this one here. That was a complex number. After after differentiating this, our answer was this. That was minus 3 into 3x minus 1 all over the square root of, now again I said it's not so proper taking the square root of a negative term. All right, so for this now, I am free to rearrange this. That means I'm having the positive term before the negative term. So that would now be something that looks like 6x minus 9x squared. This looks much more proper. All right, if this is true, my final answer will now be simply minus minus gives you plus. So my final answer will now be dy over dx is simply equal to 3 all over this one here, that's root 9x squared plus 6x. This, okay, so this to I, then minus minus gives you plus this one here, that becomes 3 into 3x minus 1 all over the square root of, this is 6x minus 9x squared. So I'll have this. Please take note that these two things are not the same thing. This is positive positive, this is positive negative, so they're not the same thing. One final step if you want to, so this could be your final answer, or if you choose to, you can factorize 3 out of this. All right, can we factorize 3? Fine, let's take 3 out of this. If I factorize 3, that will be equal to, so take out 3 from both sides. 3 is off here, becomes 3 into, so 3 into, if I take off 3 from here, I'm left with 1. It becomes 1 all over the square root of 9x squared plus 6x this to I plus, take off 3 from here, I'm left with this. That becomes 3x minus 1 all over the square root of 6x minus 9x squared. So this now becomes my final answer. So this is how we solve this question. For more content, simply subscribe to this channel. See you in our next class.